Hi guys. All right, so here's day 5. I broke it up into 2 parts, so it'll just be 2 smaller parts to be easier. So I gave a challenge. You guys can go ahead and pause it. You can try doing the challenge, and then there's, all the work just to see if you could do the 2 things from the previous day. All right, so what is today about? Today's about margin of error and confidence intervals. So a little bit of like listening to me right now. So first, just just listen to me talk a little, and then I'm going to relate it to something I saw on the TV the other day. If any of you guys are watching, especially like Cuomo's things, he gives a lot of statistics. Okay, so it says the vast majority. I'm going to start reading right here. The vast majority of the statistics that have been done so far have been descriptive. Descriptive is right here, where we measure how a data set looks. We look at the measures of central tendency, the mean, median, the mode. We look at the measures of dispersion, which is the standard deviation, mainly interquartile range. In 9th grade, you guys did some of this, and we did review a little of the box plots. And you have seen the histograms on TV. They're always plotting the hospitalizations, per day, and the deaths, unfortunately, per day. All right, so anyway, so most of it's been descriptive. So it says we will now investigate a more powerful branch of statistics known as inferential. The goal of inferential statistics is to use the sample, and that's what's going to be big here. We can use samples to infer, right, to predict what we think the real true population would be. So here it says the use of samples to infer properties of the population. This is done by using probability and sampling variability to estimate how likely the sample is given a population with certain parameters. All right, so it says we're going to begin our investigation into inferential statistics with the most basic question: how can we estimate the population if we know a sample mean? All right, so look, what I want to do is I want to show you, I just screenshotted this from when I was watching the conference. I knew I wanted to use this, so then I just went on after and I just screenshotted this. So this is what's so cool. Just to relate what we're seeing on TV, in real life here with what I was going to teach you anyway. So it says New York Governor Andrew Cuomo said on Thursday a screening of 3,000 people found nearly 14% tested positive for antibodies for the coronavirus, suggesting that 2.7 million residents across the state may have been infected with this disease. So as soon as I saw this, like right away, I wanted to check and see if this was like correct with this 2.7 million. So I went on and looked at how many people are in New York State. So New York State has 19.45 million people. So what he's saying that if we use this sample, right, this 3,000 is not all the people, right, in New York. He sampled 3,000 people to see if they've already had the coronavirus, right? They were out and about. He said they surveyed people that were just out in grocery stores and places like that, and he found that 14% already have it. So if we take 14% of the whole population, right, that's where he's getting this number of 2.723 million people. So by using a sample, he's trying to infer and come up with conclusions about our entire population. Okay, so I'm not going to say anything about his 3,000 or anything like that, but that's just an example of what we're going to look at today. So again, we'll just get into this. Okay, so another example I have here for you is. So like we could talk about this as being grades. So look, this is what I'm going to say to you. All right, so let's pretend these are all like test grades on, like, say, the Algebra 2 Regents, right? So let's say that this sample is like East Meadow High School. Let's say this one is Syosset. Let's say this one is, what other schools are out by you guys? I don't know, I could use some by me. But anyway, these will just be all different high schools, okay? Now, if we take all of those averages, right, from all the high schools and we average those, right, that's where we can come up with what we think the entire population might be. So maybe Cuomo is going to go out and keep doing, 3,000 or 5,000 or whatever per day, and then he's going to average all of those. The more samples you take, the more likely you are to then come up with what the real true population would be. So we take a whole bunch of individual averages and we average them. And that's where you can come up with a possible average for the population. Okay, so here's what I did here. So I did this in the calculator. So I took heights of 16-year-old males, right? Now, these are 200 sample means. So that means, like, maybe, again, I went to, like, all different high schools, and I came up with, oh, what's the average height for 16-year-olds at your school? And I got it from the nurse's office. And then I went to another high school. And I said, oh, what's the average of yours? What's the average of yours? So all these little blue dots represent averages, so sample averages from different high schools. Then we take that and we find the average of the average. So we say it's the mean of the sample means. So it's kind of like the mean of the means. So here's our X bar, 65 point, I'll just say 65.3, blah, blah, blah. And then the standard deviation of the sample means is 0.750. All right, and it says when a population is too large, like New York State, to get a population mean, we use what's called the sample mean. And remember, I said this one, mu, they do tend to use for population, and this one they do tend to use for sample, although our calculator only uses X bar. But when you get to higher level stats, that'll be more important. For now, it doesn't matter which one you use. So this is used to predict at some level, like a confidence level of like where we think the true mean might lie. So I'm going to show you how to do this 95% confidence interval. And here's the formula that you guys are going to memorize for me. It's the mean plus or minus 2 standard deviations. And that should seem a little familiar, that 95%, right, from 2 days ago when we did 2 standard deviations out, right, with the normal curve. Remember when we did this and we went 2 deviations out, 1, 2, 1, 2, and then this represented, remember we filled out from our notes, this represented 95.4% of the data. So that's where that comes from. Okay, so let's do our first question. And this is not hard. Like the math is like very, very easy to do. Okay, so the first question says, using the given data, values below, create a 95% confidence interval. Okay, so all we're going to do is write down our formula. So it's going to be the mean plus or minus 2 standard deviations. So 65.4 plus or minus 2 standard deviations. So 65.4 plus or minus 1.5. Okay, so you're going to do 65.4 minus 1.5, and that's where you get 63.9. And then 2. And now you're going to do 65.4 plus 1.5. And this is called your 95% confidence interval. So let me explain what this means. So the true mean, the real mean, right, that we can't get all the data for, they're saying lies somewhere in this interval. Okay, so it's when you can't get all the data and you only have samples and you take a whole bunch of samples and you average those samples. That's what this mean is, and that's what the standard deviation is. But if you take that mean and you add or subtract 2 deviations, it's saying that, hey, we think the real true mean is somewhere in there. So now this next question says, could 64.2 be the actual one? Well, could it be? Yes, because it lies within the 95% confidence interval. Right? If we look up top here, doesn't it lie within this, right? 64.2. Could 62.6 be the actual mean? And the answer is no, because it doesn't lie in the 95% confidence interval. Okay, so again, all we're doing is we're taking a whole bunch of samples, right? A whole bunch of like sample means from like either different schools or, different heights or, like the governor said, different tests from people, and you're averaging those. And then from averaging all the different ones, you can come up with what you think the real one might be when you can't get all the data. All right, so there's a special name for when you do 2 standard deviations. So this number right here that you add or subtract to both sides, right? That has a special name. It's called the margin of error. So we're going this way and this way, the same amount. That amount that you go is called your margin of error. So in that last question that we did, the margin of error was 1.5. Okay, that's something they ask you sometimes too. Remember, some of you guys might go on to statistics next year at East Meadow, and you definitely, almost everybody has to take some sort of statistics class when you're in college. So that's why I didn't want to skip this, and I wanted to still teach it to you, because it will come back, and you'll be happy that we did it. Hopefully. Okay, next one. If the mean of an SUV is 4,080 and the standard deviation is 200, state the margin of error and the 95% confidence interval for the true average. What might the real one be? Okay, so I like to always just set this up right away. Oh man, I don't know why that's happening. Okay, so mean plus or minus. Oh my goodness. Yeah, I don't know why this is happening to me today. Okay. Let me write that down again. Okay, let me just delete that. All right, X bar was 4,080. The standard deviation was 200. Okay, so we're going to do the mean plus or minus 2 standard deviations. So 4,080 plus or minus 2 times 200. So 4,080 plus or minus 400, right? So now we know that the margin of error is 400. That's one thing they wanted. Margin of error is 400. And now just do 4,080 plus 400, 4,080 minus, and that'll give you your confidence interval. And what does this confidence interval mean again? It just means that I'm 95% confident that the real true average weight of an SUV is somewhere between those two values. Okay, that's what it is when you can't get all the data. Let's try this guy. It says in 2013, approximately 1.6 million students took the critical reading portion of the SAT. The mean, the modal, and the standard deviation were calculated to be, respectively. So that means this one is the mean. The second one is the mode, which we don't need, and this is our standard deviation. Our modal is just mode. And they want to know which reflects the 95% confidence interval. So here we go. And we don't even have to do all the work. See how they're leaving it like that for us? So 496 plus or minus 2 times 115. And we don't even have to really, I mean, we can see that these are not it because those are the wrong means, right? And then this one can't be it because they didn't do twice the 115. Twice 115 is 230. Looking good? All right, so the real average is there. All right, and then I want to talk about this. So we'll talk about this usual, unusual for a second. So if you want to cover this up and like try doing it, you can, and pause the video, but otherwise we'll get into this. So it says Elizabeth waited for 6 minutes at the drive-thru at her favorite fast food restaurant the last time she visited. She was upset about having to wait that long and notified the manager. The manager assured her that it was very unusual, that it would not happen, and that it would not happen again. So a study of customers commissioned by this restaurant found approximately normal distribution results. So it says the mean time was 226 seconds. Now I notice right here this is in minutes, so I better just convert this, right? So 6 times 60. So if we convert that, that's 360 seconds. You have to be in the same units. All right, and the standard deviation was 38. It says, given these data and using a 95% confidence interval, was her time unusual? Okay, so let's look. So I did the confidence interval, and I came up with 150 to 302. So what do we think about 360? Does 360 fall in this interval? Like what the real true wait time is? No, it totally doesn't. So it is unusual. So yes, it's unusual. And you can say that it doesn't fall in there. Okay, so look at this little chart up here. And again, I wish I was in front of you because I like to stand there and do things visually, you know, in front of you. But look, if stuff falls, think about this as the curve, right? The bell curve. Right, stuff that happens all the time, or all the data is falling here, right? Isn't it unusual for somebody to get a perfect score on the SAT? Because that's, you know, good example for you guys. Isn't it unusual for them to get somebody to get like 100 on it, right? Isn't it unusual for somebody to be 7 feet tall? Isn't it unusual for somebody to be 4'2", right? So unusual is all the way out at the ends. Usual is inside. So that's why if you fall in the 95% confidence interval, that's usual. If you fall outside of it, it's unusual. And I don't know if you guys have ever seen when you go through drive-thrus, sometimes you can see it on the inside. They have like a little clock, and it times how fast they give you your food. So have you ever been through the drive-thru and they ask you to pull up, right? And they're like, oh, we'll bring your food out to you. Well, sometimes they're being timed, and then that data goes to the goes to the company. So they want to, push you up so it looks like they gave you your food. Okay. And I just want to check out this one as well, because these were ones that were on a Regents. Obviously, we're not taking it, but who knows if some of you will in August or what. So I might as well just show you. So it says in a random sample, so now they're giving you like a dot plot of 250 men in the United States, age 21 or older, 139 are married. The graph below simulated samples of 250 men 200 times, assuming that 139 men are married. So that data was entered into the calculator, and then the calculator can be programmed to actually run like a whole bunch of what's called a simulation. It's like pretending that we went out and we took all these samples, and they came up with this mean and this standard deviation. It says, based on the simulation, create an interval that represents the 95% confidence interval. So here we go again. So we're going to go 138.905 plus or minus 2 standard deviations. And after we do that, it says round to the nearest integer, we get 123 to 155. Okay, so you guys can do that and round. And now here's a good question. It says the study claims 50% of men 21 or older are married. So 50%, how many did we have here? 250? So if we took 50% of 250, that's 125. So does 125 fall in that? Yeah, and we would say again, yes, because it falls within 95% confidence interval. Alrighty, and last little bit here. Okay, so it says an orange processing plant received a truckload of oranges. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges from the truckload. Identify the sample and the population. So this is where I would be asking you this, and usually kids always tell me the right answer. The sample is going to be the 3 pails, right? And the population is the truckload. And then last part, state one conclusion that the quality control team could make about the population if 5% of the sample was found to be unsatisfactory. Well, I'm going to give you something to memorize first here. If we have 5% or less of something happening, 5% or less is always going to be considered unusual. Okay, always. And think about your bell curve. Right? That's all the way out here, right? 5% or less is all the way out here. So that's always going to be considered unusual. So if 5% was found to be unsatisfactory, then that's okay. That means that 95% was good. Okay, so that's actually okay. So we always can accept the fact that 5% or less is okay. All right, guys, and I think I'm assigning no homework on this day. All right, thanks. Bye.